Okay, welcome back to the reef tutorial of this summer school. Today we will start doing things with actual computers, with actual hands on actual keyboards. And I apologize in advance for the people on the live stream that not everything that I'm going to present will be doable by them, but just like we can't share the wireless password through the internet, I cannot hand out the keys to a 10,000 core cluster through the internet because someone will find very nefarious use case for that kind of compute power. So nonetheless, people online can continue just with what we call the local runtime. You will see that during the lecture, how to do that, and just happily continue. Okay, so what did we do yesterday? I believe I told you that resource management is upon us. You will run on clusters where parts of your computation come and go, and you have to deal with that. Prices change of the resources. You might be able to scale up your computation at will, given sufficient funds. You might have to scale it down because, well, other people pay more for the resources. The other part that I'm trying to convince you over this whole 5-day workshop is reef provides a useful abstraction in this world, right? And today we will do kind of the simple most application in this world. And of course, towards the end of the lecture, I hope that we'll see that resource-aware machine learning is an interesting question to work on. Before we do this, I want to quickly point out that we do have a website, and I want to browse to it if I can. Let's see whether I can convince the projector to show. Oh, looks good. Oh, there's my email. So, and I want to point out one particular part of it, and that is, number one, there were some questions on the mailing list regarding slides. I will put the slides of my talk up on here a couple of hours after the lecture. The reason that I can't put them up before the lecture is because I added them up to the very last minute based on how far I got yesterday, right? So that's why I'm not sharing them before. But you will find the slides on this website. And if you click on the continue reading link, they are embedded here. You can download the PowerPoint. If you happen to give talks about reef at other places, you're free to use them. Just credit me with all the hard work that went into the many animations. Okay, then we do have a mailing list, which is hosted by our friends at Google Groups. If you find that you have trouble using reef and all that, please subscribe to that and post your questions there, because we have a fairly international team working on reef in different organizations, and someone else might be able to help you faster than I can. Okay, so that was the reef website. It's reef-project.org. So that's a very useful website for you to get to. And now back to the actual programming. And just change to that again. Ooh, blue, black, wonderful. Okay. So, back to the slide deck. So what we're going to do today is an embarrassingly simple distributed program. I call it Hello Reef, and it kind of has all the pieces that any reef program has, besides any actual functionality. So the only thing it'll do is it prints Hello Reef to the console of another computer. In that sense, it is a distributed program, just not one where you actually harness the compute power of a remote machine. Okay, so what will Hello Reef do? It will allocate a single evaluator. Those were the little rectangles in my pictures from yesterday. Then it will submit a single task to it, and that task will go ahead and print Hello Reef. Slightly more visual. So we submit a job to Yarn, and then Yarn will go ahead and give us a driver, right? Yesterday I mentioned that everything in the driver is event-based. That includes the start event. So when your application starts, you get an event called start time. In this case, the application goes ahead and says, hey, I want to, on this resource requester, I want to submit a request for one evaluator with 64 megabytes of memory. That'll be plenty to print Hello Reef. So we are on the safe side here. Then what will happen when you actually do this, right at the end of this, when you do the submit call, is we translate that into a Yarn resource request and send it back to the resource manager in the cluster. Now, after a while, maybe never, you will get your allocation, depending on how important you are on that cluster, whether or not you have credentials on it and all that. When you get an allocation, you get an event that we call the allocated evaluator. The allocated evaluator, forget about all the lines that are in between. Oops, what is this? There we go. Allows you to submit a task, right? And I will explain all of these lines during today's lecture. For now, just understand that, okay, I get an allocated evaluator. I have a box running there, right? This little box there is mine, and I want to run something there. So, okay, we submit a task to it, and Hello Reef will run. So far, so easy. Now, the goal of the remaining 53 minutes of this lecture is for you to run this. So, okay, I didn't tell you what the actual task is. That's so simple. It's a task is just a callback method that gets a byte array, produces a byte array. The byte array is sent by the driver. The return value is sent back to the driver. So we really don't care what's inside. And in this case, it just prints out Hello Reef and returns null at the end and is done. Okay. So these were only 2 events that I talked about right now, right? Yesterday I mentioned a lot more events that are fired towards the driver in the course of a Reef program. And I didn't talk about them. And in the code, you will actually not find event handlers for that. And someone asked me yesterday about kind of default behavior. And that's what we have here. So there are a couple of other events in Reef that we generate, but that we have default handlers for. And I have them roughly organized by time. This isn't really true, right? Because you could have many evaluators in parallel, and then they happen in any order. But per evaluator and per task, they happen roughly in this order. So what you could get, and what you actually get in this task, is a running task. Whenever we can confirm that the task you sent to a machine to run is actually running, right, and didn't crash on the way and all that, we fire an event called running task. The default behavior of that is just to put it into the log file and move on with life. Then, of course, your task could crash, in which case we generate a failed task. A failed task has the default behavior of shutting down your application, right? If your application itself does not implement fault tolerance, then Reef will make it so that, well, it doesn't, and it crashes in an orderly fashion, and you will see this on your Yarn application list as a failed attempt of running an application. And there are a couple of events to which we react by shrinking your footprint on the cluster. The completed task and active context, I'll talk about what active contexts are, they both represent a machine that you can run another task on, right? That's when it becomes available to you to run yet another task on it. Let's say after the initial task is done. In those cases, the default behavior of Reef is to shut down the evaluator, give it back to Yarn. So if you do nothing, your application will shrink to the point that it's gone. And in the case of Hello Reef, what is actually generated is the completed task, upon which we shut down the evaluator, and if there are no more evaluators, we shut down the driver, and the application ends. Then, of course, the same can happen on the evaluator level, that you crash the whole thing, in which case we also declare shutdown, and then there are a couple of more which we just put into the log. We will see all of these events later in the lecture when we actually build a fault-tolerant machine learning application which has to react to failed tasks, right? Which has to react to machines becoming unavailable or available. But for now, we can rely on the default behavior. Okay, let's run it. You all know how to do that, right? No? Okay. I have bad news. First, we need to compile it. This is the part of the lecture where I will run around and kind of help you set up your computer. And Sergey, who's somewhere here in the room, will help me with that. Sergey is over there. He's from the Reef team at Microsoft. Yingda is up front here. He will also help us where you hit problems. Unfortunately, we will not be able to come through the camera and help people online. So they will just see nothing, basically, for the next 10 minutes or so. OK, so what you need to install on your computer or your terminal.com account, it's kind of up to you which one you want to use, is Java, Maven, protocol buffers, a Git client, and a Java development environment. Are you all? Yes?
So just a quick announcement that the Reef website seems to be down.
Oh, interesting.
So it's a WordPress not capable of handling so many connections.
Right. I have a good explanation for that. In order to make
GitHub, right?
Yes. In order to make room for the cluster that we're going to use for the summer school, I shrunk the virtual machine that runs the website to less than 1 CPU. So it's running on a fractional CPU. So you all hitting it at the same time means that, well, that poor little fractional CPU is overloaded. We can fix that, but then our cluster gets smaller, so it's a bit of a trade-off. Okay, do you all know how to install these things on your computers? I see a couple of Apple logos on which Java used to be installed. I don't know whether it still is installed by default. Linux machines on Ubuntu, just install apt-get install Maven or Maven dev. That has all the dependencies in there that you need to install. And on Windows, you just go to the websites and download the packages and install them. So let's take a 10-minute break or so for everyone to do that. And if you have questions on how to do that, just raise your hand and we'll come and help you. Oh, and maybe while I help you, we will cut this out of the video, right? Okay. As we go down the list, it gets fewer and fewer people. Okay, if you punch in Git, do you get its help? Okay. I'll give it another 5 minutes or so. The last command was just Git. Excellent. Okay, so everyone now has the dependencies, or some of them are still downloading. Let's just hope that that completes while I'm talking. When you compile reef, we have 3 software projects within reef. We have reef, tang, and wake. And reef happens to depend on wake for its messaging. I mentioned this remote messaging that we support, such that all the events that happen on an evaluator get forwarded to the job driver. That's a library called Wake that we also developed as part of reef. And both Wake and reef depend on tang, the configuration mechanism. So when you compile reef, you need to first compile tang, then wake, then reef. Because otherwise you will not satisfy the dependencies in the right order. So if you try to compile reef without having first compiled tang, you will get an error message saying, hey, can't find tang, can't compile it. Okay, so in order to compile tang, wake and reef, they are all standard Maven projects. So if you have ever interacted with Maven managed projects, it's all the same stuff that you've seen 100 times before when you compiled Hadoop or any of those. So what you do is you fetch the code from GitHub. And we are on this github.com/Microsoft-Sizzle. There you will find all the various projects that we have, tang, wake, reef, and a few others that are not subject of today's lecture. After that, you just go into the folder and then you do mvn skip tests clean install. The skip tests is mostly for your convenience because we have a fairly extensive set of test suites that takes like 10 minutes to run through. So if you just skip them, things go faster. And if everything goes right, what you will see is some printout like that which ends in build success. If you don't see that, then something went wrong. And of course, on your computer, when you run this, you will see substantially more output in between this command and this build success. But look for the build success. Second thing that you need to compile, as I was mentioning, is Wake, which is our messaging library. Same thing, fetch it from GitHub, compile it, and you will see at some point the build success message. Lastly, you need to compile reef. And this is almost the same things. So you fetch it from GitHub, but then we made a branch for the Machine Learning Summer School, which contains some code that's currently not in the reef releases. So you need to check out that branch with git checkout MLSS. That's the branch that we're going to use for the rest of the Machine Learning Summer School, where there's some additional code in there that we didn't merge yet into the master version of reef. And then you do the same thing, right? It's just mvn clean install, and a minute or two later, you have the all success message. Okay. So for those of you who have installed the dependencies, did you follow along and did it work? You have a question? Are those slides shared? The slides I will put up on the Reef project website after this.
Okay. I wasn't able to follow you when you were
Oh, okay. Sorry about that. There we go. Who has done the git clone on Tang? Awesome. I lost a few people. You have to stop me. That's a good thing. Who has compiled it? Who of those have seen the build success? Okay. So who's still on the way to the build success? Okay, I'll wait for a minute. We might again be bandwidth limited on the git clone, but that shouldn't be too much data that you need to download. Yes?
I'll come over.
Yeah. Yes? Is it all caps? Okay. Yeah, thanks. Yeah, I'll say it when we get back to that slide. Thank you. Okay, who has seen the build success on Tang? 1, 2, 3, a couple of people. Who still needs this slide to see the commands? 1, okay. 2. Right. For those of you who already have the new accounts for the wireless, it's probably advisable to switch to that. Because at least in my experience, it's a lot faster. Okay. For whom did the build success appear so far? That's about as many who tried, I suppose. Who's still trying to get the build success to appear? Okay. Is there an error message that you're getting, or is it just taking time? The git clone takes a while. Oh yeah, and when you compile things, maybe I should explain why you are sitting there and downloading half the internet. When you compile things with Maven, like this MVN command here means compile it with Maven, Tang itself has dependencies on other software libraries. And Maven goes ahead and downloads them for you as part of the compilation. Given that Tang is not the worst offender here, you will have great fun compiling reef, because that in turn depends on Hadoop, and Hadoop depends on everything that has ever been written by mankind. So it might take a while. Yeah, I didn't calculate for that. I've only taught reef tutorials so far for small groups. And 100 groups, yes?
Have you thought of sharing a virtual machine already configured?
Excuse me?
Have you thought of sharing a virtual machine?
Yeah, we do have, if you do it on terminal.com, all of this will go a lot faster, because they have faster network than we have in this room.
I mean like adding to the project an
Yeah.
script or a background or something already set up for test.
Right. So people do this with Yarn clusters and Hadoop clusters. Reef itself is quote unquote just a library, right? So the really interesting bit that is much harder to install than Reef is actually just to set up a cluster. And that we have provided for the summer school. That's the Azure cluster that we need the new accounts for to access. We can, but you need the library to code, right? And coding in a virtual machine is a bit awkward. Yes?
Although he helped me install Maven, so I'm not sure what went wrong.
Okay.
So when I tried that,
So-
it said command not found.
Where's Maven installed? That's this interesting question.
Wait. Here, inside applications is where
Okay.
Sergey put it.
He also needs to put this onto the path. Where is Sergey? He's up there.
He did.
Okay.
I believe so. On the previous terminal.
Because it doesn't find Maven, right?
No, yeah.
HMEN. Yeah, it's not on the path. Echo. Oops. PAT and H. Yeah, it's not on the path. So what you need to do is you need to set up your path to point to include that bin folder,
Oh, okay.
and then it should work.
Okay, thank you.
Hi.
I'm having trouble compiling this. It says that it has some trouble like on the tests,
Oh, skip them.
but I tried and didn't go.
Skip tests. So that should work.
That's what it did. And
You have Java 1.7.
yes,
Default compile. See the full stack trace. Can you scroll up a little?
sure.
Do you have Proto-C on the path? If you punch in Proto-C, what happens? PRO.
Like this?
Yeah, you have it. And do a -- version. Proto-C space -- version. Okay.
So I need to put this path.
No, but it is in the path already. So this is wonky because it should just work. MVN version, MVN - version. You have all the right dependencies. Oh, you're on Java 1.6.
Oh, I see.
You
So
see-
I need
you-
to switch this.
You need
Java
to.
home.
There is a control panel. If you hit Command Space, there used to be. I don't know on the newest version of macOS. Java. Yeah. There used to be a control panel where you can switch which Java version you are using.
Okay. I'll
And
check
that seems to be your problem because
Okay.
we do require Java 7. macOS comes with Java 6.
Oh,
so you
I
need to
see.
point it to the newer version.
Yeah, this is brand new. So and
Yeah.
I'm new to macOS.
Okay. Yeah, I'm old to macOS. I'm new to Windows, interestingly enough.
So, yeah, I had the same problem and I tried installing Java 7, but then it gives my laptop as an old one. So, what do
Okay.
you suggest I do?
You use terminal.com. There you have an account?
Basically can't do much. with
Yeah.
this.
I mean, it's the easiest way for you to get the requirements, right? Because on terminal.com, you can just use apt-get to install things. It's an Ubuntu machine, right? So you can do apt-get install. Sergey would know which package exactly to install on terminal.com.
Okay, thank you.
Which is the Git for the reef checkout? MLSS 2014 or
It's,
for the reef, right?
yes. So you're checking out, oh, you need to git checkout MLSS, all caps. MLSS is all caps. Okay. I have to kind of move a little bit further. We'll try to help you on the email list during the rest of the day. Who has compiled Tang successfully? Well, that's, more than I hoped for. That's great. I mean, these things are hard, right? I mean, equations are universally understood. Installing software on 3 different operating systems in 6 different versions is hard, right, by comparison, especially in a setup like this. So don't feel bad if it doesn't work. Just post your problem on the mailing list. Hopefully we can help you or you can help each other with the various issues. So what I've seen so far as issues that come up is macOS versions that are either too old to install Java 7 or too new to still have Java in the default installation. If you have a too old macOS version where Java 7 is not available for you, there is tough luck. There is no way that we can give you a version that will work. For those of you, I would suggest to use the terminal.com Linux machines. If you have a too new version where Java is missing, you need to install Java from oracle.com. If you have a version of Java installed, which is around the 10.8, 10.7 releases of macOS, that version is Java 6 by default. If someone can figure out how to change the default to be Java 7 and post it on the mailing list, that would be very, very helpful. Because those of you who have that issue will run into a compile failure of Tang, right? It will say there's a syntax error, which is in fact not a syntax error. It's a language feature that only was introduced in Java 7. Okay, who has tried and succeeded in compiling Wake? Oh, also not that few. That's good. It's the same thing. I will make these things available after the lecture. The last step was compiling reef. Who has succeeded in that? Okay, we have an audience of 5. That's awesome. Yes, thank you for pointing that out. There's a typo on the slides or in the repository, wherever you choose to believe your truth is. In the repository, it's actually MLSS all capital for the checkout command. Let me fix that on the slide such that it's fixed on the version that I'm going to upload later today. Okay. Good. So I want to briefly mention how to run things for those of you who got this far or for those of you who want to try later today or tomorrow. So now that we compiled it, we can actually attempt to run it. To run it, I have to tell you a little bit about the various, what we call runtimes Reef supports. So Reef can be run in 3 ways today and in 4 ways in a couple of weeks. The first way is you run it locally on your machine. In that case, all the containers that I drew as rectangles on the slides, they will be processes on your local machine, which is awesome because you can connect a debugger to it, you can look at things as they are happening, you don't have to interact with the cluster, which will always introduce more latency in your development cycle. So this is mostly used at development time to test things, to make sure that things work. It's of course not the best way to scale, right? If you sit in front of your tiny little Ultrabook with 8 GB of memory and you try to run things there, that's not the environment to actually where you scale. For that, we support Yarn. Yarn, as I was mentioning yesterday, is the resource manager that ships with Hadoop 2. Another way of saying this is, on any Hadoop 2 cluster, your Reef programs will work. And that's, of course, great if you already have a Hadoop cluster that you have access to. You just need to coerce your administrator to upgrade that to Hadoop 2 or newer. After that, you're good. And, of course, that's wonderful if you already have a cluster. Lastly, and that's the other way of obtaining a Hadoop cluster that we will use in this lecture, is you can use HD Insight, which is Hadoop hosted on Microsoft servers for you. So you don't have to install it, you just have to pay for it, and Microsoft will operate the cluster for you in the cloud. And that's one of those clusters is what we will use for the remainder of the lecture. So we will interact with the local runtime. We will interact with the HD Insight runtime in Reef, which is not much different from the Yarn runtime, right? Because HD Insight is a Hadoop cluster in the cloud. There's very few things that are special about it compared to a standard Yarn cluster. But we will not interact with the Yarn runtime because we just don't have a physical cluster standing around here that we will have access to. Okay. So what we can do is we can run this Hello Reef program that I was mentioning earlier on the local runtime. This is always a good test whether everything works. And I suspect that we will go down from 5 to 3 people in the next step. Try running this from the folder where you compiled Reef. You're still downloading Java? Oh, crap. So, who saw something like this on their screen when they tried it? Did it say at some point completed? Awesome. We still seem to have 5 people. That's awesome. Plus the millions who are on the live stream, of course. Because they are not bound to the wireless in a lecture hall. So they might have followed along. So now those of you who have seen this or will see this later today will wonder, where's the Hello Reef, right? Because you just ran it, it didn't print Hello Reef. Well, remember, the Hello Reef was printed on a quote-unquote remote machine, or actually in this case, another process on your machine. So what you will find in the folder where you ran this is, there's this folder called Reef Local Runtime. Inside of this folder, you will find a folder called Hello Reef dash some fancy number. That fancy number is just a timestamp. So if you run Hello Reef over and over again, you will get one of these folders each and every time, right? And so this is the runtime folder where all your jobs will have their log files stored. Then inside of that, there is one folder per job. Each time you submit a job, we create a new folder and store all of the output there. And lastly, there is another folder per virtual container. That again, they are numbered. They are called node 1, node 2, node 3. And whenever you start one, they also get a timestamp as a folder name. It's a way for us to make things unique. And inside of that, you will find this file called standardout.txt. That's where all the things that were printed to standard out, like Hello Reef, will come out. Yes? One slide back. OK, this one. OK. You got what you needed? Awesome. OK, so this is where you will find the Hello Reef. I will spend the last 9 minutes or so not to talk about anything more, but instead I will show you the code. And tomorrow we'll go over how to run this thing in the cloud, because I hope that by then more people will have all the stuff installed and we can try things. OK. Is this the right one? I hope. OK, let's see how this works on the screen. Not that good. OK, let me change the font size or screen resolution. Go away. Sorry about that. Does this work on the projector without it killing us? Kind of. Alex, do you know what the native resolution of the projector is?
It would be either XGA, so 1024 by 768, or 1280 by.
OK. This 1280 by something. This one?
Yeah, one of them.
Let's see how that looks like. This looks good. OK, let's do that. OK. I want to walk you through the code that you actually just ran or that you just watched on the slides fake run. So I was mentioning that inside of the Reef driver, there are all sorts of events exposed to the application. This is the Hello driver that actually ran, for those of you where it ran or that you saw running on my slides. This guy gets, as I was mentioning, there's a start event. Yes? Let me try. I think I can just go into this fancy presentation mode. This kind of works, right? OK, so inside of this Hello driver, which we conveniently called the class that is the driver, there is a start handler. As you can see, this guy implements an event handler of start time. So this is the class that we will fire the start event to. The start event is fired by Reef when everything's all right in the driver and it can start computing. It can start doing things. In this case, you remember from the slides, it just goes ahead and asks for one evaluator with 64 megabytes of memory. Right? We could just as easily ask for 100 with a gigabyte each or 2 gigabytes each. Of course, this will not fly on your local runtime, right? Because if you have 100 gigabyte that you need to allocate, very few laptops will be able to handle that. Now, the second event that it fired later on, that I also had on the slides, but this is the actual code that does it, is to submit an task and a context. I will go over what task and context is tomorrow. So this is how it's submitted, and it binds here. We tell it which task to run. So let's look into the hello task. So a task is this piece of code that runs on the remote machine, right? This is the basic building block of your algorithm. Later on, we will have a task that just sits on a pile of data, computes gradients, and sends them to the driver, right? And the driver then does updates and performs all the machine learning that is necessary based on top of these gradients. And as I was showing on the slides, again, this thing just prints out hello. There's nothing special about it. Question? Someone? No. Okay. So that's all there is, but there's one piece of code that I didn't show you, and that is the client that actually submits this, right? Because just because you've written the code, it doesn't magically run on some remote cluster in the cloud, right? So that is in the class hello reef, and we have many of those. And that submits things. I will go over that again tomorrow because it requires some slides that I didn't have the time to go through today. So I think given that we have 4 minutes left, the best I can do is be here for 4 minutes, answer questions. And then tomorrow we will do this again with hopefully more people having the requirements installed. Okay? Thanks. Ooh.